Hello, I'm Oren Jiang, and today I will be discussing how to do the 2006 AP Calculus BC exam free response question number 3. Okay, we have an object moving along a curve in the xy plane at position x of t, y of t at time t, and we are given both x prime and y prime. This is a calculator problem, so we can plug both these equations that were given into the calculator, which I have already done. Part A, find the acceleration vector and the speed of the object at time t equals 2. Okay, so the acceleration vector is just the derivative of both the velocity vector at time t equals 2. So for the x part, we can take the derivative at time t equals 2 to get 0.395, and by doing the same thing for the y value, we get negative 0.740 for acceleration. Now in this part they also ask us for speed. So we have the equation for our speed, which is x prime of 2 squared plus y prime of 2 squared. Okay, so we plug this into our calculator. And we get an answer of 1.207. That's part A. In part B, they ask us to find the time t for which the curve has a vertical tangent line. Now, tangent line can be found by dy over dx. That's the tangent line slope. So dy over dx is equal to dy over dt over dx over dt. So the time where this will have a infinite slope or no slope is when dx over dt equals 0. So we set dx over dt equal to 0. Okay, so we have sine inverse of 1 minus 2e to negative t equals 0. By taking the sine function of both sides, we get 1 minus 2e to negative t equals 0. And taking that into our calculator, going to the solver, we get that t is equal to 0.693. And to make sure that this is indeed an asymptote with a vertical tangent line and not just a hole in the graph, we can check that dy over dt at this t value is not equal to 0. And so we have 4 times 0.693 over 1 plus 0.693 cubed. Now clearly this is not equal to 0, so this is the answer. Okay, moving on to part C. Let m of t denote the slope of the line tangent to the curve at the point x of t, y of t, and write an expression of m of t in terms of t and use it to evaluate the limit as t approaches infinity of m of t. Okay, so m of t is just equal to dy over dt over dx over dt, as we have shown in part B. Okay, so by putting our functions into this equation, we get this as our m of t function. Okay, so we take the limit of this as t approaches infinity. Okay, so this is going to 0. This part is going to 0. So we are left with 0 times 1 equals 0. Okay, last part, part D. The graph of the curve has a horizontal asymptote at y equals c. Write but do not evaluate an expression involving an improper integral that represents this value c. Okay, so c is equal to the limit as t approaches infinity of y of t. Because as we can see, as we have a horizontal asymptote, it is the value as t approaches infinity. So how do we find this value? We are given the initial condition that time equals 2 of 6, negative 3. So using the fundamental theorem of calculus, the limit as t approaches infinity of y of t is just equal to negative 3, which is y of 2, plus the integral from 2 to infinity of 4t over 1 plus t cubed dt. And that is the answer to part D. Finally, if you need more help on these type of problems, I would recommend 2012 AP Calc BC FRQ number 2, which is also a very good parametric problem that is pretty similar to this one. Thank you, and I hope this video helped you a lot. Bye bye.